Okay, first assessment of the semester later on this week. This can be tough. I'm not gonna lie. It's pretty long, and yeah. Okay, I want you to convert the fifth root of 18 into exponent form. This is easy. You don't need a calculator. Okay, here's what this means. You write 18 down. It's to the first power, so you put a 1. And then you get rid of the, you simply underline the 1 and put the number that's in the root's index, 5. That's all you do on that one. Okay, now multiplying roots. Multiplication operation insinuates there's a 3-step process. So if you know when to start and stop, that's the way to go. So 3 times 2 is 6. And then I make my cubed root. 3 needs to go in the index. Then I take 80 times 128. 10,240. Now I know that seems like a huge impossible number. Nope, you can. Then the second step, you drop your 6 like a bad habit, and then you start trying to divide this by numbers that are perfect cubes. So here's my list, perfect cubes. So I'd start at the end probably. 10,240 divided by 1,000 is a decimal. 10,240 divided by 729 is a decimal. 10,240 divided by 512 gives me 20. So that's what I want to go with. I want to bust this into these two factors here. So I rewrite my cubed root as a product of 2 cubed roots times, and then I put 512 first, and then 20. So I eliminate the cubed root of 512 because that has an equal of 8. Then I simply multiply 6 by 8, and that's 48 cubed root 20. Okay, that is how to execute a multiplication of radicals. Now to execute addition of radicals, we make a table and we simply put each one here. So 3 cubed root 10, 2 cubed root 80. Okay, so on my perfect cubes, 10 is already simplified, so I don't need to worry about that. Now with the 80, I can maybe divide 80 down by something. Going to have to. So 80 divided by 64 is a decimal. Divided by 27 is a decimal. 80 divided by 8 is 10. So I drop my 2 times cubed root times cubed root. So I put 8 and 10 in that order. The 8 goes first because the 8 cubed root of 8 is the one that gets eliminated. And that's equal to 2. Okay? So I multiply 2 by 2. You multiply. Now, people see that adding and they think they add 2 and 2. Well, no. You times. 2 times 2 is 4 cubed root 10. Now, what I have done is I have gotten the same number under the root. So I keep it at 10 and then I add 3 plus 4. To get 7 cubed root 10. All right, now I look to simplify a radical that contains variables. So what I want to do is simply break this into different cubed roots of every factor. So cubed root 250, cubed root x to the power of 7, and the cubed root to y to the 8th. Now the 250, I try to divide it by a perfect cube. Okay, so 250, start at 216. It is not divisible by 216. Then 125. It is divisible by 125. Okay. By the way, what you should do is make a cubed root. Okay, because you're going to pull as much of this expression out as possible. Okay, so I put 125 and 2. So the cubed root of 125 gets replaced with its equal, which is 5. So 5 is placed out, 2 is placed in. Then x the 7th. X, 3, 4, 5, 6, 7. So I circle 3 at a time because it's a cubed root in the index. That gives me 2 full circles. Okay, so x to the 2nd, and there is an x left over. Y to the 8th. Okay, that's going to be 8 different y's. And then that's a cube, so triples. If that's a 2, it's doubles. If it's 4, it's quads. Okay, that's 2 full groups with 2 remaining. Okay. If you can do that in your head, great. Okay, that's the first part, simply working with roots, radicals, and simplifying them. You will need this root sheet. Okay, that's kind of obvious. Now, to the next page, my job, it doesn't say in directions, that's my fault. We need to solve these equations. So the first move I make is to make a little box and put what power the x is to. It's to the 2/3 power. Now, there's no parentheses, so it only belongs to the x, so I don't need to write q, okay? The next move I make is to identify how many answers this has. It would have 2 because that's even on top. Now I'm going to map out a game plan down here. Okay, I see my variables to the 2/3 power, so to eliminate a fraction power, we take it to the power of its reciprocal. But before I do that, I check the front, and I see a 2, so before that I'm going to divide by 2. And there's no addition or subtraction, so I divide by 2. That's 16, so x to the power of 2/3 equals 16. Then we take each side to the power of 3/2. Okay, so taking it to the 3/2 power cancels, and I just get x, because that product is 1. X to the first is just x. And then I take 16 to the power of 3/2. So I don't need the second button. I'm just going to go 16 caret 3 ABC2, and I get 64. So it could be 64 or negative 64. Okay, no, next one. We have a parentheses with x minus 5, and this is written horribly. It's to the 5/3 power minus 73 equals 170. So what's going on with my x? That's the first move. Well, it's in a parentheses with a minus 5. And the power is 5/3. Okay? Now, I am going to want to simplify this equation using my q. Now, I still know how many answers there are. It's an odd number on top, so there's only 1. So let's rewrite this with our q. So q to the 5/3 power minus 73 equals 170. And then I make a table so I remember to bring back the x minus 5. Okay, now I go to work. To eliminate a 5/3 power, we're going to do a 3/5 power. We don't have anything in front of the variable, so I will not need to divide. I have a minus 73, so I will need to plus 73. 170 plus 73 is 243. Now it's time to do the 3/5 power so that the 5/3 goes away. Power 3/5. I like to use parentheses when I do my reciprocation. So 243 power 3 ABC 5. Got 27, but now the 27 transfers here. Now I don't need this other side because there's only one answer, okay, because of the odd power that I had at the beginning. So x is 32. 27 plus 5. Okay, now the next one, we have 3 times the square root of 2x plus 5 equals 30. Okay, now I don't have a power on my x. Instead, x is underneath a root. Don't use q, okay? And also don't worry about how many answers there are. That will work itself out, okay? See, with these powers, I'm in a good position, okay? So, the first thing I need to do is put a number in the root's index, a 2, okay? I will undo that by taking it to the second power. Now, I look in front of the root. I have a 3. I will need to divide by 3 before I do the second power. And then I do not have any plus or minus taking place outside the root, okay? So I'm ready to go. I divide by 3. That makes 10. So I have the square root of 2x plus 5 equals 10. Now I do my second power. This cancels, giving me the expression 2x plus 5. 10 to the second power means 10 times 10, that's 100. Then I simply subtract 5 and divide by 2, so that's 95. So 2 times x equals 95. Then I divide by 2. 95 divided by 2 is 47.5, and that is the only answer I'm able to come up with. So again, you see the power, know how to get rid of the power, okay? Look in front, you have to divide, plus or minus, nothing, okay? Same thing, sometimes you have to reset your equation and simplify it into q. Then I do the same thing. Now again, if we have a square root, 2, you take it to the second power, okay? But then you need to look before the root for division and then after the root for plus or minus. Now I have 2 more equations on the back side. X to the power of 6. That's what's going on. Okay, having it to the 6th power means I will be looking for 2 answers. How do you undo a 6th power? With a 6th root. Do I have anything in front of x? I don't. I don't need to divide. I don't have any adding or subtracting. I'm ready to do my 6th root. Okay, x equals, because that cancels. Then I go 6, second caret 140. Okay. Anytime I'm doing a root that does not have a 2 or a square or regular square root, I go that index, second caret 140. And I get 2.28. So I could have 2.28 or negative 2.28. Okay, now I don't have x to a power, okay? So I'm not concerned about how many answers. Instead, I see that x is inside of a root, okay? So what kind of a root is it? It's a square root. So I will undo the square root by using a second power, okay? I circle the root. There's nothing before. I don't need to divide. There's no adding or subtracting behind the root, so we're good. We can go right to our second power. So this side cancels, and I'm left with 21x plus 1. Now the other side, I need some scratch paper because it is not just a number to the second power, it is an entire expression. I duplicate the expression and then I do the 1, 2. So I take 1x times 1x, I take 1x times 5, take 5 times 1x, and I take 5 times 5. So this is 1x to the second power. This is 5x, this is 5x, and this is 25. So blank x second plus blank x plus blank. Step 1 is this crap over here. So I get 1, 5 plus 5 is 10, 25. So now I come back here. 1x to the power of 2 plus 10x plus 25. This is going to be a factoring problem. Anytime I have to do this crap, okay, makes it a factoring problem. We need our boxes, but first I need to move everything to one side. Well, leave this side alone because that's where x to the second's at. I get rid of this side. Subtract 21x from 10x. Subtract 1 from 25. And that gives me 1x to the power of 2. 10 minus 21 is negative 11x. 25 minus 1 is 24. Now I see there are 3 terms, so that's the GCF and T box. Again, anytime you have to use scratch paper, we're going to have to factor. Okay, GCF, no negative, x on everything, no, and then it's just 1. Okay, so get rid of that, and then we go into our T. 1 times 24 is 24 positive, sum of 11. 11 being negative, okay, so 1 and 24, nope. 2 and 12, that's 14. 24 divided by 3 is 8, which gives me a sum of 11. So 11 is negative, that means my 8's negative, and a sum means the signs have to be the same. Okay, now A is 1, so I just need 2 parentheses. And XX minus 3 minus 8, and that gives me 2 answers, F1, F2, and again set those equal to 0. That gives me 3, and that gives me 8. So again, with the square root, think second power, okay? And then look in front of the square root, okay? Now on the second power part, if you have a whole expression to the second power instead of just a single digit, okay, that's going to make it tough. You're going to have to go to your scratch paper, then get everything to one side, then do your GCFT. Okay? That's the equation solving part. Okay, these are simplifying the product, okay? So 6 times 6, 6 times negative 7i, 7i times 6, 7i times negative 7i. Okay. Now, because we're multiplying conjugates, meaning it's a positive and a negative of the same exact expression, I don't need to find these because they're going to add up to 0. So 6 times 6 is 36. 7 times negative 7 is negative 49, I to the second. But then I to the second is actually equal to negative 1. So I multiply, and that's positive 49. Then we add those. Gives me 85. Okay. Now for my second one. Okay. Well, now when I see radicals, okay, and you don't need to put 2's inside, okay, don't worry about that. Radicals need to have coefficients, so this square root of 5 would get a 1, this square root of 5 would get a 1, okay? So I know exactly what I'm doing. I go 7 to 7. Neither 7 has a square root behind it, so those are two constants. 7 to negative 1. Now 7's empty, but negative 1 needs its square root of 5 behind it. Now I go to the 1. 1 times 7, but the 1 needs the square root of 5, and the 7's a constant. 1 times negative 1, and 1 needs a square root of 5 behind it, and so does negative 1. 7 times 7 is 49. 7 times negative 1 would be negative 7. I just attach the square root of 5 onto the product. 1 times 7 is 7. Attach the square root of 5. Now again, it was stupid for me to even do that because these just end up canceling. 1 times negative 1 is negative 1. 5 times 5 is the square root of 25. But the square root of 25 is simplifiable because it's up on the board it equals 5. So I multiply negative 1 by 5 to get negative 5. And then again I add these together. 49 to negative 5. That makes 44. Okay, and there's that nasty graph. I don't want to do a cube root. Put a square root. Okay, changing the cube root and the index to a second. Okay, so I block off the middle. That's 0. That's going to be our origin. Now we're dealing with square roots. So these are the numbers I want to pick. 1, 4, 9. You can keep going. And I'll also do the negatives. Okay, now we got a times. But you see in the square root we have a minus 3. Well, that knocks off what I'm trying to do. So I undo the minus 3 by adding 3. So that's 12. That's 7. That's 4. That's 3. That's 2. That's negative 1. That's negative 6. Okay. Now I'm ready to roll. 4 times 2 second caret, then parentheses 12 minus 3, parentheses has to end, so the square root ends minus 6. It would be 6. If you can do this in your head, that's fine. If you know that 12 minus 3 is 9, square root of 9 is 3, times 4 is 12, minus 6, 6. Okay, now I go replace the 12 with 7. I simply delete the 2 and cover the that with a 3. So that's 2. Up. Negative 2. Up. Negative 6. Okay, let's reset. Or no, I don't need to reset yet. Okay. Domain error suite. I like domain errors, means I don't have to find these because they don't exist. Okay. Now, you need to graph the middle first. That's your origin. 1, 2, 3. You can, by the way, the x's would have to go by 2's. The y's would go by 1's. So 3, negative 6. 2, 3. Or 3. Down 1, 2, 3, 4, 5, 6. Now, since all of these were domain errors, I write the word stop right there in the middle. And I go up 4, negative 2. I want you graphing that first and then these. Bottom up, middle up, I should say. Okay, so 4, negative 2. 2, 4, down 1, 2. And connect them as you go. 7, 2. 2, 4, 6, 7. And then up 1, 2. 12, 6. 2, 4, 6, 8, 10, 12. Then up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, I can keep going that way. I could have kept going with numbers and, 9, 1, 4, 9, 16, 25, 36, and adjusted it. So I make an arrow, but not there because that's stop. You got to get the arrow in the right place. Just graph the middle first, right? Stop if that's a domain error, okay? Then you go up, graph the rest.